Alright, so we have a problem where we have a dime. This dime has a mass, and it has a percent nickel by mass, which we have to kind of understand what that means, but we'll go through that in a second. And then it asks, how many nickel atoms does it contain? Let's just start there. We don't have to worry about anything else yet. So we have a single dime, some coin, right? 2.35 grams of it. It's 83% nickel by mass. So we can go directly from mass. Ultimately, we're going to have to go to moles. Okay, because that's where we have to go. And then from moles to atoms. There is no direct path. If you think of my concept map of Mole Island, there is no direct path from mass to atoms. We have to go mass to moles, moles to atoms. Okay. But we have to know how much nickel we actually have. We have 2.35 grams of nickel. But what does that mean? I mean, grams of dime. Sorry. We have 2.35 grams of dime. And only 83% of that is nickel. So conceptually, you should be able to see that we just need to multiply those. But let me see if I can explain it to you in a little bit different way. We have 2.35 grams of coin. And then in that coin, say we have 1 gram of coin. We could say we had 100 grams of coin. We could say anything we want here. We have 0.83 grams of nickel. That's what it means to be 83% nickel. We don't care what the other 17% is. All we care is that 83% of this coin is nickel. So if we multiply those two things together, we end up with actually 2.0 grams of nickel. That's how much is in a dime. And at the end of the day, that's all we care about. So then with that, how many nickel atoms does it contain? Well, we go 2.0 grams of nickel times, nickel is 58, just from the periodic table, oh my gosh, 0.69 grams of nickel, 1 mole of nickel, and then in 1 mole of anything, we have 6.02 times 10 to the 23rd atoms. All right. This 3 sig figs, this one is 2 sig figs. So our answer here will have 2 sig figs. And when we do this, we get an answer 2.0 times 10 to the 22nd atoms of nickel. Okay. So, that's where we are. That's part 1 of the problem. Now, suppose that each nickel atom has a diameter of this. Okay, so for every atom, it has a diameter of 3 times 10 to the minus 10, 10 meters. We're going to line these things up in a long line. All these atoms. We want to know ultimately how long this is. How many meters. Okay? So this is just a problem of 2.0. Oh my gosh, let me see if I can fix that for you guys. I'm sorry. Let me do it in a different color too. So we have 2.0 times 10 to the 22nd atoms. And 1 atom is 3 times 10 to the minus 10 meters. So again, we're paying attention to our units. Atoms goes away. We're left with meters. And we get 6.2 0 times 10 to the 12th meters. That's how long our line would be. You know, all of this is just something where it tells you if you took all the atoms, you know, if you took all the nickel atoms in a single dime and spread them out in a single line, which of course it would only be one atom high, but still, if you could somehow spread these things out in a single line, that line would be amazingly long. And so it's just to show you how, you know, it's to try to bring these very small things into a real world. That's why we have these kind of problems. But even then, conceptually, it's kind of tricky. But hopefully that makes sense, and hopefully everything's good. So there you go.